Alright, in this video, I'm going to be talking about the 74ls247 IC chip. I'm going to be talking about what it does and how different things actually use this chip. So as a precursor, right, you should watch the video I have on 7-segment displays. Just go into this video with knowledge on 7-segment displays and on binary, I guess, in general. Yeah. Okay, so alright, so what the chip does is it takes one BCD number and then converts it into a 7-bit binary code. Okay, what's the point of this? Basically, right, BCD, as we know, right, is just 4 bits, which will give us one decimal number. For example, this is 0, or like this is 5, you know. Um, and as we know, one BCD number cannot exceed 9. So yeah, so this is the limit, and then that's it. And then this is invalid. So we're looking at one BCD number, and then we're going to convert it into a 7-bit binary code or 7-bit binary number. And we're going to use this code to actually activate the segments of a 7-segment display. So a 7-segment display, which agak looks like this, has these different LED segments here, which can be individually powered. So basically, this 7-bit binary code, right, will each bit in the 7-bit binary code, 1, 2, 3, 4, 5, 6, 7, each bit is going to correspond A, B, C, D, E, F, G, correspond to each segment. And the decimal point is not included because we don't need this when we're converting a normal one singular binary coded decimal number for the 7-segment display. So the point of this chip is to get a BCD number, to produce a 7-bit binary code, and then to display that on a 7-segment display, or in other words, to display a BCD number on a 7-segment display. Okay, so this here is a table. It is, okay, really? It is a table that shows for every single possible BCD number, right, what will the output of the 247 chip be. So if in the case of 0000, which is 0 in decimal, right, it will produce 011111 for for the 7-bit binary code lah. In this case, yeah, it's GFEDCBA and not ABCDEFG. But anyway, and then like for example, 1000 for BCD, which is 8, will produce 111111 as the code. Then on the right here, it shows how the chip is connected up. So we can see that BCD this, right, is actually the BCD input. One thing to note is that in BCD, right, or here, A is the least significant bit, D is the most significant bit. Again, if you don't know what the hell I'm talking about, just watch the video I have on binary. But yeah, okay, that's that. Then we have F, G, A, B, C, D, E. These will be our outputs that, as you can see, is literally put into a 7-segment display. One thing to note is that can you see here, the 7-segment display is very oh, I forgot, is this common anode or common cathode? I think this is common cathode. Basically, right, this chip only works with this specific type of 7-segment display and not the other one, because it actually produces it does not really produce a logic 1. What it does is, if this is logic 1 or bunny ears powered, it will actually ground this pin. Okay, if you watch my 77 display video, you would understand what the hell's going on lah. And then it will ground that LED, letting it power up. So that's one thing to note as well. Do you need to memorize the configuration of this? Honestly, I'm not too sure if in the examination they'll tell you, oh, this is pin A, this is pin D, this is pin C, this is pin B. Personally, I'm not going to memorize this at all. You just need to remember the least significant bit is A always in here, and the output of right of the 7-bit binary code, right, will ground the pins if it is a higher or logic 1. And I guess you need to remember, not really you need to remember, you can note that these 3 pins are tied to high voltage. You don't need to know why. So yeah, honestly, this is a very simple video, and that's pretty much all you need to know for the 74ls247 chip. Alright, thanks.